Greetings, class. It's Mr. Kablan again, and I'm here to present the final lesson for Chapter 6, which deals with solving linear systems. Before I begin, please make sure you have a ruler handy because you will need it for this lesson here because we were drawing lines. And just make sure you also have a nice sharp pencil because, again, we need to draw accurate lines here. All right, so before we begin here, I just want to just do a quick summary of the different types of equations we've seen in this chapter here. So what you see in the screen here, okay, are the three forms of the equations that we've looked at. Now, for about 80% or even more of this particular chapter, as well as the previous one, okay, the formula that we've been using a lot is this one in the middle, the y equals mx plus b. So remember that this equation over here, okay, this is an example of an equation of a line in slope y-intercept form. All right, so as we mentioned before, okay, all three of these forms that you see on the screen, okay, are exactly the same thing, just represented in different forms here. And remember in a previous lesson, what we did was to take this form here, the first one, okay, and then from there, change that into slope y-intercept form. And remember that this first one, this was what's called standard form, all right? Now, in the fourth lesson, when we were looking at the different ways to graph, okay, one of the ways that we learned here was when we saw an equation that was in this form, which I've called in brackets intercept form, okay, we plotted the line using the x and y intercepts. And remember, there was a way to solve for that, just solving for the x and y algebraically, which we're going to revisit as well. Now, you're probably wondering, why am I presenting these three forms for today's lesson? Well, if you look at the three forms over here, of the three forms, okay, only two of them will be useful for us when we're graphing. Okay, so when an equation is in standard form, okay, it just tells you, okay, again, when you're looking at this one over here, basically what you have to understand about the standard form is it's just a form of the equation where the a, and the b, and the c are just numbers. And basically what you have to understand that is that when it comes to graphing, okay, from that form alone, okay, there isn't much you can do. So question is, if we get an equation that is in standard form, how in the world can we graph it? Well, that's what today's lesson is about. In order for you to graph any lines, they can only be in one of two forms here. So for example, if you take a look at the two forms over here, and based on what we've covered, okay, these two over here are the only two forms you can use that's going to help us graph a line using 2 points. Okay, so if you have an equation in standard form, okay, you must change it into one of these two forms depending on what a question is asking for you. Now, in today's lesson, we're going to look at an example where we're actually going to just have these forms in general. And what we just want to also revisit are the techniques behind it. Now, once you look at your review sheet, you're going to see that you do need to analyze which form it is to determine how you're going to graph that. Okay, so that's one of the examples we're going to look at. Now, one of the other things that we're also going to look at is that when we're drawing lines right now, okay, you know that when you have two sets of lines, you only have two scenarios up until now. So up until now, your first scenario that we've seen is that we've seen how a line is parallel, or two sets of lines are parallel, meaning they will never meet. Okay, so we're going to quickly revisit that. Okay, and up until now, we know that lines meet at one point, okay, specifically at a 90-degree angle, where we had to where the two lines met and the slopes are negative reciprocals. Okay, so we've discovered two ways. Now, believe it or not, lines, okay, when they meet, can only meet at one point up until now. And what we're going to see in today's lesson, I'm going to introduce you to a third way that third relationship that lines have when it comes to how they meet. Okay, so there's going to be a lot that we're going to be covering in today's lesson here. All right, so let's jump to it. So just a little bit of a heads up as well. Okay, so again, I always use this when I'm finishing off a chapter or even a course, and I'm going to talk about it here. Basically, where you leave off in this particular chapter, okay, is basically where you're also going to start in grade 10. Okay, the only difference is that in grade 10 you'll be learning this exact same thing, but you'll be learning how to do it algebraically. Okay, so this is a very important lesson uh, uh, because you are going to carry this on in your next course in next year. All right, so just to give you a little bit of heads up there. All right, so what is a linear system? Before we begin, if you take a look at this diagram, notice we have two lines here. We have the green one that's going up to the right, okay, and we have a red one that's falling down to the right. Okay, so as you can see, all lines will always meet at one point, okay, like I said, up until now. Now, what you have to see here is that when you're looking at lines here, okay, what you want to do here is to understand that you have learned several ways how to graph lines, specifically in this chapter, how to graph it using the slope and the y-intercept, okay, and how to graph intercepts. So in this lesson, we're going to revisit when and how we know when to use them, all right? So let's summarize this lesson over here just in terms of what we're gonna cover here. So like I said, a linear system consists of two or more linear equations or two or more lines, okay, that and they're presented on the same coordinate Cartesian plane here. All right, and what we're going to do in today's lesson is we're going to come up with a solution, which you're also going to know as a point of intersection. Okay, and basically what happens here is that anytime two lines meet at a single point, okay, that's an example of a solution. And one of the things that we're going to revisit that we saw several chapters ago is how to perform what's called a left side and right side check, okay, just to make sure that our answers are indeed correct here. All right, and up until now, you've learned about two types of ways that lines meet or don't meet. And today, like you said, you're going to learn a third way. So what we've covered so far is that when we look at two lines, we've always seen somehow that a line has met at only one point. So that's an example of one solution. Okay, and basically, if you look at two lines, notice that they do meet at a single point over here. Okay, and just by looking at equations, okay, when you're looking at two equations and you're looking at the slope and just the slope, as long as the two slopes are different, okay, they will always meet at one point. Okay, so that's how we know that two equations will meet at one point. Okay, just by looking at the slopes. All right, so I've designated the one solution there with a red dot there just to show you the one point that these lines will meet. Okay, and a few lessons ago, okay, we discovered what it means for lines to be parallel, okay, and that's an example of what's called no solution. So you notice in the diagram over here, we have two lines that will never ever meet, okay, and we discovered in that chapter is that when we have parallel lines that they will never meet, okay, they would have slopes that are exactly the same, okay. So in this case here, okay, there is no point that these lines will ever meet because they are parallel. And remember that in this case over here, just to double check what we have y equals x plus 2 for the top line and y equals x for the bottom line. So they both have a slope here of 1. So since they have the same slope, these lines are parallel, okay? So that's what we've covered, okay? So we've looked at one solution and no solution. So the third and new type of solution that we have here is what's called an infinite number of solutions, okay? And what this means here is that if you take a look at these two graphs, okay, notice we have the exact line for both graphs. The only difference is the equation. So the question is, well, how do we know if a line has an infinite number of solutions? Well, if you take a look at the top equation and the bottom equation, notice that all the bottom equation is a result of multiplying each of these terms by 2, okay, or doubling the top equation. Okay, so you can see that as long as you take a look at two equations, you notice the equations are multiples of each other. Okay, you're going to see that that's an example of an infinite number of solutions. And we're going to actually solve for it just to show you how exactly that works here. Okay, so this is just a nice little introduction to how we're going to do that. Okay, so in both cases, not only are the same line, okay, well, they are the same line, but they both have the same slope and the same y-intercept. And it's called an infinite number of solutions because the points will satisfy every part of the line in both lines that you see in this diagram. Okay, so we're going to see how we can actually figure that out simply just by looking at an equation. All right. Okay, so when you have an infinite number of solutions, that means they're never ending, and that's exactly what infinite means. All right, so the first thing we want to do here is to take a look at just 3 pairs of equations, and all we want to answer here is to figure out how many solutions they have. Now, what we want to do in each case here, okay, is to take a look at the slopes. So if you take a look at the first equation over here, notice that the first equation here has a slope of 4, okay? And the second equation here also has a slope of 4, okay? So in this example over here, both of these lines have the same slope. So remember that if lines have the same slope, okay, this is an example of parallel lines. So that means these lines will never meet. So since these lines will never meet, this is an example of zero solutions, okay? Because remember, a solution is where the lines will meet, the one point, okay, or the infinite number, all right? Now, if you take a look at the next one, okay, you probably notice they look a little bit different, okay? Notice the top equation, okay, looks different from the second one. Now, remember that when you have this top form here, which is the intercept form, okay, this is only useful when you're graphing, but when it comes to figuring out what the slope is, okay, it's not of any use to us. So what we have to do for this one before we actually answer this question is to change this equation, okay, into the form y equals mx plus b. Because remember that what we want to do here is to look at the slopes to figure out how many solutions there are. So by taking this over here, notice we have 6x plus 3y equals negative 12. And remember that when you're converting equations into the form y equals mx plus b, you always have to leave the y term alone. So I'm just going to put a blue box around it just as a reminder that we leave this term until we absolutely have to deal with it. Okay? So let's take a look at what we need to do next here. So that means this 6x, okay, needs to go to the other side. Now I'm going to just do something a little bit different here. Remember that we want in the form y equals mx plus b. So this negative 12, okay, is already part of the b part. So what I'm going to do here is I'm going to take this 6x, okay, move it to the other side of the equal sign, but I'm going to squeeze it in front of that negative 12 there like this, okay? So this is something a little bit different. And the reason for that is I want it to be in the form of y equals mx plus b, okay? Now for the final step, we just need to solve for the y now by dividing each term here by 3. Now, when you take the negative 6x and divide by 3, that's going to give me 2. And we take the negative 12 and divide by 3, that gives me negative 4. Oh, look at that. Okay, notice that this first equation, when you arrange it in the form of y equals mx plus b, okay, they both have a slope of negative 2, and they both have a y-intercept of negative 4. Okay, so since the two equations have the same slope and the same y-intercept, they're actually the exact same equation, this would be the example of infinite number of solutions, okay? So this is how you can now, again, analyze the two equations of the lines to figure out whether a linear system has 0 solutions, 1 solution, or infinite number of solutions. You always have to go back to the slope, all right? All right, last but not least here, again, this one over here, always take a look at the slopes. We have a slope of 2 and a slope of negative 5. Now, as I said earlier, as long as two lines have different slopes, regardless of what the number is, okay, they're always going to meet at one point. So that would be an example of one solution. So what you have just seen here, again, we don't need to graph it, okay? If I ever ask you, just taking a look at the equations, okay, determine which equations have 0 solutions, 1 solutions, or infinite. This is exactly how you approach it. So remember, to determine the value of the slope, you always have to express it in the form of y equals mx plus b. All right, so now that we've seen how to analyze equations, determine how many solutions there are, let's actually determine how we can find out the solutions by graphing. So make sure you have your ruler handy because we're going to need it. All right, so back in the beginning of this lesson here, okay, remember that what I had asked you was, when you have the three forms, the standard, the slope y-intercept form, and the intercept form, remember that only 2 of them came in handy when it came to actually graphing. So for this question over here, okay, again, it's guided for you, so you'll know exactly what method to use depending on what form you have here. So you notice what we have here for the top equation is y is equal to 1 over 4x plus 1. Now you notice that in this first equation over here, okay, it's in the form of y equals mx plus b. So anytime you have an equation in the form of y equals mx plus b, okay, you should always graph it using the slope and y-intercept method, which we'll revisit again in this example. Now, in the second example, okay, notice the x and the y are on the same side. and the number is on its own here. So this is an example of what I call intercept form. So when you see the x and the y on the same side and the number on the other side, we're going to graph them using intercept. So we're going to revisit how to solve for that as well. All right, so let's take a look at what we need to do here. And remember, in order for us to find the solution, we want to find out where these two lines meet. Now, you're going to be, this is also referred to as the point of intersection, which you'll hear a lot about in grade 10, okay? So again, these words mean all the same thing, okay? They're just worded quite differently in different contexts here. All right, so let's get to it here and let's graph some lines. So recall from a previous lesson in this chapter, we learned how to graph a line using the slope and the y-intercept. So I'm going to pull up those instructions again. So first things first, okay, remember we always have to plot the y-intercept first. So you notice here, you have to look for the b value, which in this case here is a positive 1. So from the point 0, 0, don't forget you just need to plot that by going up by 1. Okay, so that's step number 1. Now step number 2, we need to take the slope, okay, and then we're going to plot the second point using the slope, okay, and you're always going to start from the y-intercept. So remember that the slope consists of two numbers, okay, a rise and a run. So remember the top number is the rise, which tells us how many spots to go up from the y-intercept. Okay, so from the y-intercept, we're going to go up one, sorry. Okay, and then what we have for the 4 here is going to be a run, which is going to tell us how many spots to go right. Now, before we should have done this, should do a quick rewind here. Okay, you should always ask yourself, which direction is this line going? Okay, so in this case here, since we have a positive slope, the line will be going up to the right. So in the next part over here, like I said, we're going to use the two numbers there for the rise and the run to plot the second point here. And don't forget, we're starting from the second point. So from there, we're going to perform rise and then run. So I'm going to use guidelines there to start off with. So from the y-intercept, this red dot right there, we're going to go up 1 and then right 4. Okay, so that's going to give us the second point, which I'm going to draw. Okay, and then from here, connect these 2 points. Now, I want you to see, make sure you extend the lines because we will need it in order to answer this question. Because remember, we're trying to figure out where the two lines meet. Okay, they could potentially meet somewhere over here on the left side or on the right side, okay? Or in some cases, it could be in the middle or it could be one of these points. We have a lot of choices here, all right? So that's the first line. And again, we're gonna label it just as a reference so we know which line is which. All right, so now we've done that, let's now take a look at the next one over here. So when we're graphing using intercepts, remember that what we have to do here is we need to solve for them. And we need to solve for the x and y intercept separately, okay, by letting the opposite letter be 0. So to solve for the x-intercept over here, remember what we had to do for this one is we had to let the y equal 0. Okay, and by doing that, that will give us our first intercept here to be x is equal to 6. Okay, so remember the x-intercept is where the line will touch the x-axis. So this x equals 6 will be right there, which I plotted in the blue. All right. So for the y-intercept, okay, we have to let the opposite letter be 0. So in this case, the x is going to be 0. So what we wind up getting here will be 0 plus y equals 6. And sure enough, our y-intercept here is also 6. Okay, and don't forget the y-intercept is where the line touches the y-axis, which in this case is that. Okay, now when we connect these two blue dots here with a straight line, you will notice that they will meet at one point, and it happened to be one of the points that was already there. Okay, now it's not always going to be that case there. That's why you need to be very accurate when you're drawing the lines here. All right, now the next thing we want to do here is we just want to identify the point here. Okay, and I've just changed the color just to show you which point we're referring to. So remember that coordinates are always expressed in terms of x and y over here. So notice that what we have here is an ordered pair of 4, okay, and then 2. Okay, always label the point with the x coordinate first and the y coordinate second. Now, question is this the correct answer? Well, yes, I'm telling you to. Okay, but just in case, we just want to make sure that this is indeed a correct answer here. So what we're going to do here is we're going to perform a left side, right side check, which you were introduced to back in chapter 4. Okay, but not only do we have to do it for one equation, but we actually have to do it for both. So we're going to see two types of checks here. And in order for this solution to be true, okay, it has to check into both equations that we use in this question. All right, so you starting off the first one over here. Okay, notice that we're going to break it down according to left side and right side. Okay, so the left side again is everything to the left of the equal sign, and the right side is everything to the right. So all we're going to do here, like I said, is we're going to check in the 0.42 for the x and the y. Okay, so remember that the y is the only thing that's on the left side, so that we're going to start off with that. Okay, so that's it for that. So for the right side, we're going to plug in the x of 4 into the x. Okay, and you can see here, okay, when we simplify this, okay, we wind up getting the same. Okay, so in order for a solution to be correct, okay, the left side and the right side must be equal. Okay, so we know we're good for the first equation. Okay, so let's check the second equation here. So for the second equation, this is the x plus y equals 6. So the left side is x plus y, and the right side here is 6. So notice that the right side has already been done for us because it's the right side of the equal sign. So you can see in the next step here, we're going to put the 4 and the 2 in for the x and the y. Okay, and sure enough, okay, what we wind up getting there is the same thing. Okay, so since the 4, 2 checks correctly into both equations, okay, the thumbs up there tells us that what we have there is indeed the correct solution. All right, and just be sure you state that just to come up with just to define what the solution is. All right, so that wraps up this lesson here. Okay, and again, make sure that you're continuing on with the review here. Now, please be sure that you're checking out your solutions, which are located at the back of the review. Okay, and don't forget, in the review, the grids are already there, so there's no need for you to draw the grids there. And that wraps up this chapter, and good luck with the rest of the chapter. I will see you in chapter 7.